Hello, it's Mr. Kaczynski. I've got your quiz 5-2 solutions, so let's get started. Alright, first set of questions here says give the inequality graphed on each number line. So I'm looking at all the values that are greater than -5, as well as -5 being included, and I can tell that because it's a solid dot right there. So this is x is greater than or equal to -5. On B, I'm looking at all the numbers that are less than 1, and I'm also not including 1 because it's indicated with an open dot right there, so x is less than 1. And lastly, I've got all the numbers between -8 and -4, everything between -8 and -4 that is greater than -8 and less than -4. It's got to be both those things, including -8, but not including -4, and we indicate that like this. So this says that x is greater than or equal to -8, and x is less than -4. Next, we need to solve these inequalities. So in other words, find all the values that make this inequality true. They're an infinite number. So to solve this, you solve it kind of like an equation here. I'm going to use inverse operations, and I'm going to subtract 3.3 from both sides. That'll leave me with 10x is less than or equal to -4.3. And then I'm going to divide both sides by 10. That'll give me x is less than or equal to -0.43. That means anything less than -0.43 will solve this inequality. Anything greater than -0.43 will not solve this inequality. -0.43 is also a solution. If I were to graph that, it would be a solid dot at -0.43 and an arrow to the left. Next one, I decided to subtract 6 from both sides. That gave me 3 times the quantity of x minus 5 is greater than 12. Then I divided both sides by 3 to get x minus 5 is greater than 4. And then I added 5 both sides and got x is greater than 9. So if I were to graph that, it would be an open dot at 9 with an arrow to the right. Anything bigger than 9 will solve this. 9 or lower will not solve it. And the last one here's got a little bit of trickery to it. Not just the difference between solving inequalities and solving equations. So first I subtracted 17.2 from both sides. That gave me -2.6x is greater than -14.3. Don't forget to bring that subtraction sign down as a negative. And then I divided both sides by -2.6, and that gives me x is less than 5.5. We know that when you divide by a negative, and we're dividing by a -2.6, that flips the inequality around. So this would be an open dot, if we were to graph it, an open dot at 5.5 with an arrow to the left, meaning that anything less than 5.5 will make this inequality true. 5.5 or greater will make this inequality false. All right, so we're given an inequality here, a linear inequality, and asked to graph it. It is in slope-intercept form, so I'm going to plot the y-intercept at 1/2, and from there I'm going to go down 5 and over 2 to create the line. It is going to be a solid line, so here we go. So there's my line. Again, you can see that I plotted my y-intercept there at 1/2. I actually did it incorrectly, so we got some fixing to do here. So let's see here. We want to go 1/2. Give me a second here. So there's our y-intercept right there at 1/2, and we're going to go down 5. So it's 1, 2, 3, 4, 5 over 1, 2. So right there. Okay, and I'm just going to extend through that point. There we go. And going the other way then. So that point right there. And, oops, sorry. Alright, so there we go. So then my shading should look more, I got to add a little bit of shading right here. Okay, and the reason for the shading is that the point 0, 0, if I test that by throwing it in to the inequality, I'll get 0 is greater than or equal to 1/2. That is not true. 0 is not greater than or equal to 1/2. So the point 0, 0 does not work, meaning none of these points work. All the points over here do work. Okay. Sorry about that, but we move on. All right, next. Got this inequality. We're supposed to graph this. I guess the thing I would look at here is doing intercepts, because I see 12, it's divisible by -4, it's divisible by -3. So 12 divided by -4 is -3, and 12 divided by -3 is -4. So my x-intercept is -3, and my y-intercept is -4. My x-intercept is -3, my y-intercept is -4. This has got a mistake on it too, doesn't it? I should have a dashed line here. So let's fix that. Sorry, bear with me. Line style. There we go. Line style. There we go. All right. So now we got that fixed. Good enough. It should be a dashed line. The x-intercept at -3, y-intercept at -4. The point 0, 0 again does not work. So if we plug in 0 for x and 0 for y, we get 0 is greater than 12. And that is not a true statement, so we shade everything that doesn't include the point 0, 0 over here on the left. We're really rolling, but at least I'm catching my mistakes. All right, so which of the following points are solutions to the system of inequalities? Let's start off with the ones that aren't. And I'll come back and do the ones that are using the calculator. So I know that 5, -2 is not. So if I look at the top inequality here, if I plug in -2 for y and +5 for x, I get -2 is less than -5 plus 1. -2 is less than -5 plus 1. That'll give me -2 is less than -4, which is not a true statement, meaning B is not a solution. C. This point does not work in the second inequality. So if I plug in -6 for y and 4 for x, I get this inequality. I'll do the multiplication here. 2 times 4 is 8, and then 8 minus 2 is 6. That leaves me with -6 is greater than 6, which is not a true statement, meaning this point is not a solution. And then if we look at E, I've got here that this point does not work in the first inequality again, so I plugged in 6 for y and 1 for x. Then the opposite of 1 is -1. -1 plus 1 is 0. I get 6 is less than 0. That's not a true statement, hence why I put that cross through there, making that point not work, or solution to the inequality. All right, so let's look at the points that do work, that are A and D. That's the correct answer. And let's check those. So I'm going to plug it into the first equation. Obviously, y is -1. And then I'm going to do the opposite of x, which is -6, plus 1. And I get 7. -1 is less than 7. That's what it's supposed to be. Then again, we'll do -1 for y. And then x, or the right side, 2 times x, which is -6, minus 2. That gives me -14, and that's true. -1 is greater than -14. So you can see it works in both of those. Let's start over and look at the second one, or point D here. Y is 2. Okay, we want that to be less than the right side, which is -x, -3, plus 1. That gives me 4. Okay, 2 is less than 4, and I want it to be less than 4. So it works in that one. We'll check the other one. Again, 2 for y. And then the right side is going to be 2 times x minus 2, which gives us, -8. So y was 2, and that is greater than -8. So we're good there. That does work in both inequalities. So the solutions here are A and D. Right inequality represented by this graph. Okay, so we got a dashed line. So we know it's going to be not or equal to. First thing I'm looking at is the slope, I guess, up 2 over 3. And I also have a y-intercept of 1. So here we go. Let me fix something real quick. Okay, so let me put this inequality up here. y1 because the y-intercept is 1, y 2/3 because the slope is up 2 over 3, so there's 2/3 x. Y less than, number one, we already talked about the fact that it should be a dashed line, or that it is a dashed line, so it wouldn't be or equal to. And y less than as opposed to greater than. I want the point 0, 0 to work in my inequality. If I plug 0 in for y and 0 in for x, I get 0 is less than 1. I want it to be a true statement. 0 less than 1 is a true statement, so this is the correct inequality. Moving on here. All right, so we're graphing this system. Let me show you my answer and break this down for you. I think I actually have this correct now. All right, we've got the top one. We've got a y-intercept of 3. There it is. We got a slope of 1/2, so from that 3 I'm going up 1 over 2. And we have a solid line because it's or equal to. So there's my line. The next one, we've got a y-intercept of 1, a slope of 3. So from that 1 I'm going to go up 3 over 1. It's a dashed line because there is no or equal to. The points on that line do not solve that inequality. All right, my shading. For the top one, 0, 0 does work. 0 is greater than or equal to 3. I'm sorry, 0, 0 does not work for the first one. That's why we're shading above that solid line, above it. 0, 0 does not work. And for the second one, 0, 0 does work. 0 is less than 1, so we're shading to the right of it. Okay, so above the solid line and to the right of the dashed line is this portion right here. Last one of the best videos I've ever made and posted on YouTube. Thank you for bearing with me. Write a system of inequalities for the solutions shown on the graph. Well, the first one's pretty easy. I mean, I can see that is x is greater than -3. X is greater than -3. The second one's tougher. Number one, just because it's not a vertical or horizontal line. Number two, they don't give us the y-intercept. So let me break that down first. Okay, let's figure out what the y-intercept is. Now, I do have 2 points, and I can figure out the slope pretty easily. The slope is down 1, 2, 3, 4 over 1, 2, 3. So -4/3 for my slope. And then I do have this point right here that is -1, 2. -1, 2. So I plug that into point slope form. So there's x minus -1 or x plus 1. Because my x value is -1, and then there's my 2 because my y value is 2 for the point. So if I distribute the -4/3, I get -4/3 x, and then -4/3 times 1 is -4/3. I turned 2 into 6/3 so that I'd have a common denominator, and then I did 6/3 minus 4/3 is 2/3. So there's my y-intercept right there, 2/3. Some people thought it was 3/4. They just took a guess. I'm sure some people guessed that it was 2/3 and got lucky. You were right. So here's my actual answer. There's my first inequality. X is greater than -3. It's everything to the right of -3. My second one is y is less than or equal to 2/3 minus 4/3 x. The or equal to because it's a solid line, and less than because I want 0, 0 to work in that inequality. And if I plug 0, 0 in, I get 0 is less than or equal to 2/3, which is a true statement, and that's what I want. So there's my inequality. All right, kind of long-winded, but there's a lot of little things to talk about when we're dealing with inequalities, and lots of little things that you guys need to go through your mental checklist and fix. And me going through this for a second time, you can see I caught some of my mistakes, and hopefully now that you're watching this, you're not seeing any of my mistakes in the final product. All right, so hopefully this helps you do your corrections, and I'll see you soon.